Hi, I'm Ken Ham, President and CEO of Answers in Genesis and the Creation Museum. As many of you know, Bill Nye has agreed to debate me here at the Creation Museum on February 4th, 2014. It's really been amazing to me that as soon as many of the atheists heard that this debate was going ahead, they were pressuring Bill Nye to pull out of the debate. Many were saying that don't debate creationists because it just legitimizes their worldview or it gives them a platform. You see, many of these atheists just do not want creationists being able to get their message across. They want to stop people hearing about creation. In fact, they really are involved in censorship. They don't want young people to know that science actually supports the Bible and confirms the Bible's history. The other thing that I saw happen was this. There were atheists that were actually telling us that Bill Nye wasn't really an evolutionist to debate Ken Ham. In other words, he wasn't qualified to debate. You know, it's all right for Bill Nye to be able to make statements about evolution publicly and be applauded for that, and yet then when he wants to debate a creationist, he's told by secular peers that he shouldn't be debating them because he doesn't really understand evolution. It's just amazing to see the things that have been said. But I encourage you to watch the debate, and you can watch it live at the Answers in Genesis website. So I encourage you to go to answersingenesis.org and you'll be able to find out how to watch the debate between Bill Nye the Science Guy and myself, February 4th, 2014.
This is God's Quality Control 11.1. Here I continue my thoughts on the debate between Bill Nye and Ken Ham on Feb 4, 2014 at the Creation Museum in Petersburg, Kentucky. As we saw in the previous video, Ham attempts to attribute equal validity to creationism and evolutionary theory by placing both concepts within the realm of historical science as opposed to observational science. I must apologize if I gave the impression in the previous video that this distinction is not legitimate. It is legitimate and is pondered deeply by philosophers of science. Fortunately, as I hope I have convinced you over the years, one need not have a deep understanding of the philosophical underpinnings in order to grasp the basics, which I'll discuss here. To start, let's forget for the moment the terms observational and historical, which for our purposes have unnecessarily technical meanings. Let's call the two approaches general and specific instead. In the general approach, we use repeatable experiments and testable observations to infer general principles that we call scientific laws. In the specific approach, we use known scientific laws to infer specific details about the world around us. As you can probably see, these two approaches complement each other, each feeding back into the other, building our body of knowledge. Consider an example of the general approach. Anyone who has cut down a tree may notice that there are concentric, alternating bands of light and dark wood in the interior of the stump. These are known as tree rings. Scientists and non-scientists alike have observed for quite some time in trees of known age that the number of rings in a given tree corresponds to the number of years that the tree has been alive. Based on this phenomenon, we infer that trees in general grow in this fashion, and we call the inference a scientific law, or a law of nature, or simply a general principle. Now consider an example of the specific approach. If I cut down a tree of unknown age, although no one observed it growing, I can use the known principles concerning tree rings to infer the age of this specific tree. This, the concept I have temporarily called the specific approach, is what philosophers of science mean when they say historical science. And this is where Ham and his fellow superstitionists get it utterly wrong. Much of the support for evolutionary theory comes from the fossil record, which could be considered a historical account of sorts, but that is not what makes it historical science. It is historical science because it is supported by known principles that are derived from testable, repeatable observations. Creationism is not a historical science. It is historical only in the sense that it is based on a historical account. It is science in no sense whatsoever. That's 11.1. Thanks for watching.
The Science Guy. Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Bill Nye the Science Guy here to talk about submarines. More specifically, the USS Thresher, built in 1960. The USS Thresher didn't exactly meet a great fate in the end. Well, it sank. So, today we're going to talk about the science of why that happened.
Bill Nye the Science Guy.
In April of 1963, the USS Thresher was doing test dives off the coast of Newfoundland when all of a sudden, something went wrong. The crew tried to get to the surface as fast as possible, but the system designed to get it to the top of the surface failed. So the submarine sank, all the way down to 3,200 feet where it crushed. Now we're going to talk about the science of how to get a submarine from the bottom of the ocean to the top as fast as possible. This is our submarine of science. Well, actually, it's a glass jar full of blue water and made of metal, so it'll sink. And the reason it'll sink is because it's heavier than the water it displaces. Things that are heavier than the water they displace sink. Things that are lighter than the water they displace float. This is how boats work, and more specifically, submarines. I mean, can't you see the resemblance? We're now going to put our submarine of science into our ocean of science. And as I said, it sinks, just like a submarine. Now, to represent an emergency ballast blow, which is what you do to get a submarine from the top or the bottom, we need the air hose of science. Now, a submarine would have tanks on board that would act as the air supply. But since we don't have a real submarine, we just have our model submarine of science, we're going to have to improvise. So when I turn the button of science, we're going to watch the submarine blow all the blue water out and fill itself with air. This will make it less dense than the water, or weigh less than the water that it displaces, and shoot to the surface. Ready? Science! There we go! Just as science predicted. As you can see, the model submarine of science is now out of blue water and it's around in the ocean. So, it worked. The submarine of science became less dense, or it weighed less than the water it displaced, so it rose to the top. Now that's a pretty good idea, but there are a couple things that can go wrong with that. One of those things is
thermodynamics.
And the idea with that is that as a gas expands, it gets cold. And that's because the gas is having to do energy on the environment, and a really good source of energy is heat. There's a really good way to demonstrate that, and that's with canned air. You know, have you ever taken a thing of canned air and just sprayed it? All of a sudden your hand gets really cold? Well, I'll show you how with science. So, if we take this thermostat right here and measure the temperature, you can see that the can is 53 degrees. Now if I take this a little bit and measure it again, it's now 43 degrees. That's 10 whole degrees in just a couple of seconds.
That's cold.
So imagine if a submarine, hundreds of feet long, tried to get rid of all the water inside of it and rise to the surface through a tiny little nozzle. Well, any water that would be residual would freeze. That meant that when the USS Thresher tried to get all the water out of its system with this air like this, the tanks, and specifically the nozzle, froze.
Bill Nye the Science Guy.
So what is crush depth? Well, crush depth is what happens when a submarine sinks too deep and then it implodes. Why does this happen? Well, do you ever go swimming in a swimming pool and decide to dive to the bottom of the deep end and it really hurts your ears? Well, that's because water is really heavy. In fact, a cubic foot of water weighs 62.4 pounds. So imagine how much water is on top of you if you're at the bottom of the Atlantic. Well, 3,200 feet down. What happens is implosion. I'll demonstrate that now with our tube of science. This tube is, well, it's a tennis ball tube, but it'll demonstrate the idea perfectly. As the submarine sinks down and down and down, the water gets heavier and heavier and applies more and more pressure. all of a sudden, once it has too much pressure, it implodes, blowing the end off. Doesn't sound like fun.
Bill Nye the Science Guy.
So let's recap on what happened to the USS Thresher. It was off the coast, swimming along, doing test dives, when all of a sudden, something went wrong. It tried to get to the surface as fast as possible using the idea of buoyancy. That being, making the submarine weigh less than the water that surrounds it, rise to the surface. Well, when that happened, our canned air of science froze, meaning that the submarine couldn't rise. Because of this, it started to drift down and down and down, to the point where it reached crush depth, and it imploded. That is what happened to the USS Thresher.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
My hat or a flower, the water, a shower, some coffee or a bicycle, a frozen popsicle combination. Atomic combination matters cool, it's made with molecules. And did you ever think about the molecules? The bond is very cool, very, very cool. The stars and planets are made of an atom combination. And those atoms are so tiny that you never see them, like hydrogen and carbon and oxygen. We know that they exist, cause we see how they react. And there's only 92 of them, you know that atoms all combine. They make up molecules. Matter is all around. Atoms, atoms.
Okay, I've measured out, I'm measuring the volumes carefully for reasons you'll see in a minute. I'm going to want to change the concentration of one of our reactants here. So when I pour these together, we know what's going to happen, right? The reaction's going to tell us when it's done, right? It turns blue when it's done. So we want to time how long it takes, because if the rate changes, then the time is going to change, right? If the time gets longer, it's because the rate got slower. Okay, so I'll tell you when to start. Those of you who are timing, ready, go. Take about 10 seconds, a little more. What do we get?
10.5.
10.8,
10.5.
let's call it 11 seconds. Okay, we're only doing this approximately. Now, I want to change.
La bianca tanto ci mette 6 ore e quell'altra si vede. Ecco, ora ha cominciato. Quella della coca. No, a fare